Hello students, in this video you are going to learn about basic electrical engineering subject module number 3 single phase transformers. So in that you are going to learn introduction and working principle. So in introduction, what is meant by transformer and where we are using the transformer and working principle and operation of the transformer. So these are the things you are going to learn in this video. So coming to the module number 3 having two parts, one is single phase transformer and domestic wiring. In single phase transformer, necessity of transformer, principle of operation, types and construction of transformer, EMF equation, losses, variation losses with respect to load, efficiency, condition for maximum. This is the topics are there in single phase transformer. And in domestic wiring, service mains, meter board, distribution board, brief discussion on concealed conduit wiring, two-way and three-way control of lamps. Two-way and three-way control, that means we have a two different types of switches, one is two-way control switch and three-way control switch. So those switches, how we are using, what is the operation of those two switches, you will learn in two-way and three-way control of lamps. Elementary discussion on circuit protective devices. So in that fuse, MCBs. Next one, electric shock, precautions against shock, earthing. In earthing, pipe and plate earthings we have. So this is the module 3 content. So first, single phase transformer. So if you look transformer, if you go to any substation or power generating stations, so transformer looks like this. So almost the transformers, so bigger sizes. So where we are using in power generation and transmission. If you coming to the distribution side, so transformer size will be less. Based on the rating of the transformer, the size of the transformer will be increased. So coming to the what is meant by transformer? So here transformer is a static device which transforms electrical energy from one circuit to another circuit without changes in frequency. So that is called transformer. Transformers are used in power transmission and power distribution sectors. So even power generating stations also we are using the transformers, right? So in small size applications like TV circuits, radio circuit and electronic devices called mobile phones, mobile chargers. So if you want to charge the mobile, we need a charger. So inside the charger, so there will be transformer. So those type of transformers are small size transformers. In large size transformers are used in the power generating station, power transmission and power distribution stations. And small size transformers, so these are the transformers are used in electronic devices like radio, TV and radar circuits. So coming to the principle of operation. So transformer works on mutual induction principle. So transformer works on mutual induction principle. So generally DC generator, AC generator and DC motor, AC motor, those are works on principle of electromagnetic induction, but transformer is works on mutual induction principle. So mutual induction means, so transforms electrical energy from one circuit to another circuit without any changes in frequency, and those two circuits are mutually coupled but not electrically coupled. So electrically there is no connection between windings, primary winding and secondary winding, primary circuit and secondary circuit, but these are linked magnetically, right? So coming to the operation. So what is the principle of operation? Principle of transformer is mutual induction principle. It works on mutual induction principle. Coming to the operation, transformer consisting of horizontal part and vertical part. So here horizontal part we can see, this is the horizontal part and vertical parts are this one. These are the vertical parts. So here Horizontal part is known as yoke of the transformer, and vertical parts are called as the limbs of the transformer. Yoke of the transformer and vertical part is called limbs of the transformer. So which consisting of two limbs. So you can observe in the diagram. So both primary and secondary windings are placed on each limbs. Primary winding is having one limb, secondary winding having another limb. One supply is connected to the primary winding. So here, so primary circuit or primary winding. So you can call it primary winding. Primary winding is connected to the supply. Then so current will flows in the primary winding. So due to the current flowing in the primary winding, magnetic flux will be links. So you can observe this light lines in this core. So magnetic flux will be produced and links to the secondary winding. So it will be automatically it will links primary winding to secondary winding. It will links. So this flux linking in the primary winding to secondary winding. So there will be electromagnetic induction. So that magnetic flux will convert into the EMF, that is called electromagnetic induction. So electromagnetic induction. So both principles, electromagnetic induction and electromagnetism, is called mutual induction. So here the electric current will produce the magnetic flux is called electromagnetism. Magnetic flux will produce EMF is known as electromagnetic induction. Both electromagnetic induction, electromagnetism, both is known as mutual induction. That's what transformer works on the mutual induction principle. So based on the number of turns in primary winding and number of turns in secondary winding, so these transformers are classified into two types. When number of turns in primary winding is more than the secondary winding, number of NP is greater than NS, then the transformer is called step down transformer. NP is less than NS, that means number of turns in secondary winding is more than the primary winding, then the transformer is called as step up transformer. So in step up transformer, secondary voltage will be more than the primary voltage. In step down transformer, step up voltage will be less than the primary voltage, but currents are vice versa, currents are different. So when voltage is less, current will be more. When voltage is more, current will be less. But if you calculate primary side and secondary side power value, both will be equal. So those type of transformers are called when primary input power is equal to secondary output power, secondary winding output power is both will be equal, then the transformer is called ideal transformer. So ideal transformer does not have any losses. Inside the transformer there is no losses. Those transformers are called ideal transformer. When the transformer which does not have any loss, the transformer is called ideal transformer. Okay. So this is about principle of operation. So once again we will check this principle of operation. We will revise. So transformer generally consisting of horizontal part and vertical part. Horizontal part is called yoke, vertical part is called limbs. When primary winding is connected to the supply, so current will flows, the current will produce the magnetic flux, that is called electromagnetism. Then the current flows, magnetic flux will produce, then is called electromagnetism. The magnetic flux, primary winding magnetic flux links to secondary winding. The magnetic flux will produce the EMF, that is called electromagnetic induction. So both these two, electromagnetism and electromagnetic induction, both the principles, so together we can call it as a mutual induction. So based on the number of turns in primary and secondary windings, so transformers are classified into two types, step up and step down transformer. Okay. So this is about principle of operation. So you can clearly observe the magnetic flux linking from primary winding to secondary winding in number figure number 1, and laminated steel cores to reduce the eddy current losses in transformer. So, we are laminating the core with the silicon steel varnish. So, if you apply the varnish on the transformer, so we can reduce the eddy current losses. So, varnish belongs to the silicon material, silicon steel material. It is made up of silicon steel material. So, if you apply silicon steel laminations, so we can reduce the eddy current losses. So, this is a symbol representation of transformer. So, generally we will use for circuits while we are doing the equivalent circuit diagram of the transformer, then those cases we will use this circuit symbol. So, here you can observe N1, N2. So, two lines represents between N1 and N2 we have two lines, that is called core. So, primary winding connected to supply and secondary winding is connected to the load. So, this is about principle and operation. In next video, so we will discuss about different types of transformer according to the construction. Okay, thank you everyone.